Okay, so today we will start OOPS concept. Okay, object oriented programming. Okay, object oriented. What is object oriented? Okay, if you understand object oriented programming, so you need to know, first of all, you need to know what is object. Okay, so object is related to what these things we have to know. Okay, so object is nothing but it is a collection of data. Collection of data. Okay, collection of data. So technically we call it as properties of some data type. Okay, it will have some properties of some data type. Okay, so that we call it as object. From where we can derive this object, from where we can get this object. Okay, if you see that statement, properties of some data. Okay, so if you want to get the object, okay, so we are already writing some class, right? So inside the class we are writing some data, right? Some data we are writing, and also we are performing some operations. Okay, so class, whatever we define the class, that class also we will call it as data type. Okay, why we call it as data type? So class we have, this we call it as data type. Technically it is a data type. Okay, so data types we discussed it, right? Let me open that. Not this one. Sorry. So we have, yeah. So we have referenced data types part, right? So we still now, okay, till yesterday we have seen primitive data types, fixed size data types we have used. Okay, and also non-referenced data type also, non-primitive data type also we have used. That is string only. Okay, so along with the string, whatever we create with class keyword, that we call it as again data type. So you are creating the data with the help of class keyword, and inside that data type block, you are also processing that data. Okay, so in a class, so we define the data that we will process. So the entire thing again we call it as a data type. Okay, that comes under reference data type. Okay, why we need to call it as data type? Okay, let me explain that. So what is class? General meaning. In general, what is class? So class is nothing but classification. Okay, classification. So if you have some huge data, for example, if you take college data, Okay, you have some college data. So in college data, so what are all the data we can see in the entire college data? So you can see students data, right? You can see the faculty data. So faculty data means faculty's information. Okay, faculty data and office staff data and management data, right? So generally, if you take some college data, so you will have all these mixed data. Okay, this entire data you call it as college data. Suppose if somebody asks you to classify this data, okay, you have some mixed data. If somebody asks you to classify that data, divide that data based on the if there is a relation between some data, so based on that, so we have to divide. That is called as classification. Okay, so class is nothing but classification. Okay, if you have some raw data that you convert into different blocks. For example, if you take library, okay, so if you take the library, so all books are arranged in a format, right? So based on its category. Okay, so here also class is nothing but classification. Okay, based on the data, we will classify that data. Okay, if you have student data, so you will put the entire student data into some location, faculty data into some location. So why we need to classify again? Okay, for the easy access. Suppose if you want to access student data, you can directly go to that block or that folder. Suppose if you take your computer, if you divide it like folders, okay, you can easily access. Okay, inside that again you can create sub classification inside the students only. Okay, so you will have different classes again inside that in college class. Okay, different branches you can create. Okay, so class is nothing but, so you have some data that you are classifying. Okay, so here also what we are doing is, so we are processing some data. Okay, so before processing, okay, you should not create inside the class, you should not create some random data. Okay, so you should not mix everything into a single class. So while creating the class, okay, while processing the class, so you have to choose the corresponding data of that class, that classification. Okay, suppose if I want to create, if I want to process student to data, okay, what I have to do is, so class student I have to write. Okay, inside this block, again, you should not mix this faculty data. Okay, so similarly, if you are writing faculty data, or if you are processing faculty data, so processing means if you want to display faculty details, or if you want to calculate the salary, okay, all these things. Okay, similarly, office data. Okay, so like this, if you classify, you can easily process the data. Okay, instead of mixing it. Otherwise, if you write everything into a single class, it will be clumsy and it is not easy for processing. Okay, so why? So the generally, so when we create the class, that is the meaning of class. Okay, when you are creating the class, okay, which means you are creating some data type. Okay, data type you are creating, so that data type you can use in anywhere. Again, how we are using int, float, these data types, primitive data types. Similarly, you can use the like whatever we create, the reference data type, non-primitive data type, that we can use it in some other Again, other classes, other programming. Okay, so how I can access the data which I created in the class? How I can access the data which I created in the class blocks? Okay, so if you want to access the data, okay, suppose you created some memory location, okay, with some integer, you stored some data, okay, into that memory location. How you are accessing that data? Okay, for example, so we have this notation. Int is for allocate the memory, some value is you are storing. Okay, how you are accessing? You are accessing with the name of that memory location. Similarly, here also, coming to the class data types, if you want to access the data here, you cannot create, you cannot allocate memory directly. Okay, the main difference is when you use primitive data types, your compiler will automatically allocate the memory for your data, primitive data, because your compiler is already know. Okay, when you are using, okay, 4 bytes of memory I need to allocate, that will allocate. But coming to non-primitive data types, non-fixed data types, okay, your compiler doesn't know like how much memory it has to create. Okay, if you want to allocate the memory for your reference data types, so you have to allocate by your own. You need to allocate. There is a format, there is a syntax to allocate the memory that you have to follow. After allocating the memory, okay, if you provide some name to it, that we call it as object reference name. So whatever the memory you allocate, whatever the data you store, that entire thing we call it as a object. If you provide some name to it, that we call it as a object reference, or you can directly call it as object. Okay, so why it is object? So whenever you create data, okay, you will have, suppose if you create the memory for this class, for this type conversion class, okay, it has more than one property, right? It has more than one property. It has methods, more than one method, more than one property it has. But coming to primitive data types, it has only one property. Suppose if you have only one property, okay, so that is the reason. So primitive data types can hold only one property, not more than one. But your non-primitive data types, it can hold more than one property, more than one data. Okay, so those kind of memory location, if you allocate, that we call it as object. If you give a name like this, variable name to it, that we call it as object reference variable. Okay, what are those we will discuss, but as of now, so object is a collection of data. Okay, some properties of data type. So from properties of data type means some properties of a class. Okay, again, class. So class is nothing but some classification. Okay, when you are processing some data, okay, based on the data category, so you will create some data type. So inside that, you will store that data and you will process the data. Okay, class is nothing but collection of data and logics. Collection of data and logics. Technically, we call it as variables and methods. Okay, so now we have object. Okay, we have class. For class, we created object. Suppose if you create a object, how you can manage that object, how you can reuse that object, how you can provide the security to that object. Okay, Suppose if you want to use that object in a different forms, how you can use? So if you want to provide only overview, if you suppose you created the memory, okay, you already provided some logics and you have created some data, but you don't want to show that data to anyone. Okay, then how you can provide the overview of that data? Okay, so all these comes under object-oriented programming. So technically, the process of providing the security and providing the access to that object and reusing that object, and again reusing in a different ways, the properties if you want to reuse in a different ways, and providing like overview to that object. All these technically we call it as encapsulation, inheritance, polymorphism, and abstraction. Okay, so the object oriented programming means, okay, so you need to follow this set of guidelines. When you are creating the object, you need to follow some set of guidelines. Is nothing but object oriented programming. Okay, if you follow the set of guidelines, okay, it will be more useful. Okay, without following it, you will lose your security, you will use your data, and also it will be wasted. Your effort also will be wasted. Okay, so object oriented programming means, so so instead of every time creating some raw data, okay, so you will create limited data. Okay, so you will occupy limited memory that you can reuse. Okay, so in that process we have to do with the objects. Okay, not like primitive data types. So primitive data types always occupies fixed memory. Okay, in that case, even though you put the like suitable data or not, it won't care. Okay, by default it will occupy. In the starting of our class only I told you, whenever we utilize less memory, then only your programming speed will increases. Okay, so if you use all primitive data types, okay, it occupies more memory every time. Instead of it, if you follow the object oriented programming, so you will have more options to minimize the memory. Okay, you have reusability of like options, you have like using that object in different forms, like that we have different concepts. Okay, these four concepts using which you can perform very effective programming execution. Okay, so what is encapsulation? What is encapsulation? So encapsulation is nothing but how we can store how we can store the data into some memory location. Okay, how we can process, how to process the data. Okay, so how to store the data into some memory location, and how to process the data, and how to secure the data. Suppose you are creating some vital information, you are storing some vital information. So then how you can provide security to your data? Okay, providing security and also providing access to your data. So these three concepts will comes under encapsulation. Okay, so inheritance. So if you want to perform inheritance, you need to create more than one class. Okay, so more than one class means, so you have some data, so that if you want to use it into some other object, You already created one object. That object you want to use it into another object. Suppose student data generally, so office staff can access, management can access, and also faculty can access, right? How they can use, student data. Okay, again, without wasting the memory, without wasting the huge memory, how they can use the student data. Okay, so suppose you have, for college also, some basic college information you will have, right? Suppose basic college info. Okay, so let me put it as college info. So college information, like, so college like name, affiliated university, okay, college code, college location, and also the facilities of college. Okay, what are the courses provided by college? All this data comes under college info. Okay, suppose student wants to use that college info data. Okay, how you can access the data? Okay, so inheritance means, okay, relation between providing relation between two classes, two data types, different data types. Two data types are two classes, and create a single memory to it. Okay, so you can ask that. Suppose if we create a class for entire data, again it will comes into single memory location, right? Single memory only, right? So why this classification is required? Okay, so all the time we want to use the college information, right? So whenever we require, so that time, so we can inherit that college information. Okay, we can acquire that college information. Okay, to do that we have to follow the inheritance. So if you want to follow the inheritance, you must have more than one class. You have to provide the relation between those two classes. Then you can create a single memory location and you can access that data. So even though you create a single memory location in the backend, it will not create, of course, it creates a single memory location. Inside that, again, it creates sub memories based on its type. So you will have only one object, but so it will create, inside it will create sub memories, sub blocks for data type, each class. Okay, so inheritance is nothing but so getting some class information directly to your class. Getting some class information directly to your class. Again, when you are getting the class information, okay, providing the access to data is that that class creator. See, so whenever you are fetching the data, suppose if you are fetching the data from college info, okay, to student, okay, accessing this data, providing the access to this data, it depends on the creator of this class. Okay, so you will not get it directly, entire data directly. Okay, so suppose if they provide access to this data, then only you can access into your class. Suppose if they restrict the data inside the class, you cannot access. Okay, even though we use the inheritance. Okay, so inheritance is nothing but just fetching the data from some class directly into your class if it is accessed by the class creator. Okay, polymorphism. What is polymorphism? Okay, so polymorphism is nothing but suppose you created some logic inside a class. Okay, inside a class we have some logic. So if you want to use a logic with you using a same logic with different names, or if we have different logics with same name, we can do that. Okay, so suppose you have different logics. If you want to provide a same name to all the logics, that comes under polymorphism. Okay, suppose you have provided some name to a method, some addition method. Okay, same name you can give it to another logic, and that logic also you can use. Okay, so here polymorphism is using the same name with different forms with different logics, using the same name with different logics. This comes under polymorphism. Okay, so how you will perform? So generally we perform for the methods. Okay, with the methods only we can do the logics, right? Okay, we create different methods. Okay, we create different methods. Okay, but if you provide all the methods, for all the methods, if you provide the same name, which comes under polymorphism. Okay, not all the methods. Suppose if you want to give a same name to more than one method, that comes under polymorphism. So we have again some rules to do that. Okay, how to do? So we will discuss. So coming to abstraction. So abstraction is nothing but providing the overview of your class or method. You just want to provide the overview of your class. I don't want to share the logics. I don't want to share my data. I just want to provide the overview of my class, just abstract of my class. Okay, so using abstraction concept, you can provide the overview of your classes and methods. Okay, so using these four concepts, by following these four concepts, we have to develop our logics in Java. Okay, so in object oriented programming, these are the facilities. Generally you have these facilities. If you use these facilities to write your program, it will be processed very easily by your JVM, and also easy to reuse and easy to understand by other people, and also your data also will be secure. Okay, so one by one we will discuss. So first we start with encapsulation. Okay, this is the order we have to follow. Okay, so while like learning also, so you have to follow this order. First you have to know encapsulation. So how to store the data into some variables, how to process the data, and how to provide the access, how to restrict the access. Okay, so these things you have to know. So after that, suppose if somebody wants to access your data, how you like how suppose if you are trying to access some other class information, how to access that, how you can directly fetch, you can do with the inheritance. So polymorphism we have seen, and abstraction also. So these four concepts you have to learn in a order. So first we start with the encapsulation. So let me create new package. Some oops, I will put the package name. Inside that I'm creating encapsulation. Encapsulation. So we already seen, okay, how to create the variables. Okay, so here the variables plays the more role. Okay, in encapsulation variable plays the more role. So till yesterday we have seen how to use the local variables. Okay, suppose I want to perform some So sorry. So here, what I do is, so let me delete this. Don't I don't want to create package name as oops. Okay, I want to create the package name as encapsulation. See, while creating the package or while creating the class or while declaring the variable name, while creating the methods, again we have some rules. Those we have to follow. So we have to follow some naming convention, naming format convention we have to follow. So how to write package names, how to write class names. Okay, these we have to know. Those I will explain as of now. So let me create one package encapsulation. Okay, inside that I'm creating one class, some example one, or let me create one class as some calculator. So you need to perform calculation operations. Okay, generally what are all the calculations we perform? So we perform addition. Okay, which is a logic. So which means you require some method. Similarly, you have addition and subtraction. Okay, so this example I taken, it is easy to understand. Okay, so with other real-time example also I will explain this encapsulation part. So as of now we discuss calculator. Okay, because to start with this object-oriented programming. Okay, so it is a very good example to understand by everyone. Similarly, you can create a multiplication and I want to perform division and modular division. Okay, the difference is remainder and quotient. Mod division. Okay, like this, I have some calculations. These are the operations we have to perform in the calculator, right? So how to pass my data? How to pass my data to my methods? To my methods. Suppose you need to perform operation on two variables. Suppose you have, so let me write inside a method, int a equals to 10, int b equals to 20. Okay, so if you want to perform addition operation, what you can do? You can directly print a plus b. So this is the operation. Along that operation, after performing it, you are printing the statement. Okay, so yeah, so it will print the addition operation. Suppose if I want to, okay, still it is so again, even though you write okay multiple methods like this to process, to call your data, it won't directly call your main method. Okay, even though you write the logic, it won't directly execute your logic. Okay, it won't execute your logic. Why it is not executing my logic? I have some logic, I am printing also, but it is still not executing. Okay, that we will discuss okay after this part. So as of now, let me make it as static. Okay, so if you call some addition method, calling means if you specify that name, inside the main method, because generally main method only will execute. Whenever we execute, we have multiple logics, but this block of logic only always execute. If you want, you have to call. If you want to run the other logics, you have to call these logics into your main method. Then only it will execute the other logic. Otherwise, it won't execute. Okay, you can do like, you can call subtraction into addition, and like addition into multiplication, and the multiplication into division. You can call, if you call the division, again all the methods will be executed. Like that you can provide the relation. Okay, but the thing is, so if you want to execute any logic with the help of main method only, you can execute. Otherwise you cannot execute your logic. But here I want to execute my addition method. Okay, so how I can access this addition method into my main method? Just simply use its name. Okay, suppose if you want to use some data, how you are using that name, that data name. Similarly, so this block name you have to use to execute. Yeah, so if I execute it, okay, it is printing 30. Suppose I want to perform subtraction operation. Okay, subtraction operation on the same data. On the same data. So A minus B. We will get error. Why I am getting error? The scope of these local variables are up to this block only. I cannot access outside of my addition block. Okay, so if you want to access that A and B values, it is not allowing you to perform the operation, because these are local variables. You can access inside that method only. How I can access these A and B values across all these methods? Okay, so you just simply cut from here. If you declare outside of all the methods, you can access yeah, you can access across all your methods. But here again, if I want to call the addition method, it is throwing the error again. Okay, so why it is throwing? Okay, let me put static. When I use static, inside that A and B values are throwing error. Okay, let me put static for A and B. So now I'm not getting any error. Now I'm not getting any error. So here, why I'm not getting error here? Suppose if you call subtraction method, again you will get error. Okay, to avoid this error, again you have to define with the static here. So now this error will go. So what is static? What it is doing? Okay, so if I use static, it is simply ignoring the error when I calling that method. Okay, what is static? So as I said, while explaining the object or class, okay, so if you want to use some class information, okay, so your compiler, it is a non-primitive data type. Okay, your compiler cannot create like memory directly. Your compiler cannot create memory directly to your data. When you use static, your compiler will create the data. Okay, so not compiler. So JVM only will do that, but your compiler can understand it. Okay, so they have mentioned it as static means, okay, JVM will allocate the memory. We don't need to allocate the memory. Your compiler can understand. Suppose if you don't use static, your compiler cannot understand whether you create the memory for this data or this method, but directly it will execute this method blindly. Your compiler or your JVM blindly execute the main method. Suppose if you don't create the memory for this variable or this method, okay. So while processing, what it will print? If nothing is there in the memory, suppose so without storing into memory location, you cannot process the data, right? So without storing into some memory location, how it will process that data. So that is the reason when you don't specify the static, it is giving the error. Okay, so by default for your class, inside a class, if you use anything, it won't allocate anything. So that we have to allocate. Suppose if you mention it is as a static, so your JVM, we have inside JVM we have it's gone. Okay, let me open that screenshot. So inside JVM, we have class loaders, and also executors. When you use static keyword, okay, so loaders will allocate the class file loaders will allocate the memory. Okay, so while execution memory is already allocated, okay, there will be no problem for execution. But coming to your non-static variable, suppose if you don't define static, okay, for this variable, memory will not be allocated. Okay, so here your executor look for that memory. If it is not available, it cannot process the data. Okay, so when you define with static keyword, your compiler can understand that. Okay, so while classing load time only, memory will be allocated. So executor can execute that data. Okay, but if you don't define, your compiler doesn't know whether you allocate a memory or not. Again, memory allocation also we have to do. Okay, whether you allocate or not, your compiler doesn't know. Okay, so if you want to process the data, again you have to use the static keyword. Okay, static keyword. But the thing is, so here whenever you put the static keyword for your methods and your variables, your data, again unnecessarily we are wasting our memory location. So you may use or may not use this data, but by default it allocates the memory. By default it allocates the memory if you use or if you don't use. Okay, so like that memory will be wasted. So instead of doing that, so we have one more option, instance memory. Okay, whenever you want to use, that time create the memory, use it. If you want to destroy it, you can destroy it. Okay, so like that we have for global variables there are two concepts for local variables. One is instance and another one is static. Okay, so static memory, it will be allocated by your JVM loaders, okay, class loaders. So before executing only, so memory will be allocated and the data will be stored. Okay, suppose if you don't assign the data, by default, it will assign 0. Class loader will assign 0 based on its data type. If I run it, okay, I will not get error. See, it prints the 10. Okay, your class loaders assigns some default values based on its type. For character, it assigns some space. Okay, for integer 0, for float it is 0.0. Again for long 0, double 0.0. For boolean, by default it is false. Okay, like that it assigns default data. Okay, when you use static. Okay, suppose if you are creating local variables, if you are creating local variables into C, if you want to declare into D, you can declare, but if you want to use it C plus D or C into D, you will get error. So here you are not getting. See, same thing. Let me do with A and B. A and B. You are not getting any error. So when I do with C and D, I'm getting error. Coming to local variables. Okay. So memory will be allocated at the time of calling this method. Okay. So your JVM or your class loaders, it won't allocate any memory. When you call this method, that time memory will be allocated. Okay. And coming to this variable. So even though memory is allocated, okay, so you must initialize the value, because you cannot initialize the value with the help of other things. Okay. So, but coming to these global variables, for this, the default value will be allocated by, okay, your class loader only. But coming to these local variables, no default value will be assigned. No default value. Okay, there is no value inside this memory location. How it can do the multiplication operation? But for these global variables, default value will be allocated. For local variables, no default value will be allocated. And again, why we are not able to access these local variables outside the particular block? But how I can access these values across all the methods? Okay. So for this memory, whatever we create inside this memory, it will be destroyed once this method execution is completed. Suppose if I call this method, after printing this entire memory will be deleted. If you want to store the result value, again you have to use the return type and the data type. That is a separate memory again. Okay. But coming to these local variables, these are not instant variables. Okay. Instant purpose. Instant. Okay. We have instance and instant. Suppose if you create into C equals to some 30. This is instance. This is instant. Okay, so this memory will be destroyed once method is executed. So that is the reason these values are not, we cannot access outside of this method, because memory will be allocated, after process memory will be deleted. If there is no memory, that you cannot access. But coming to global variables, loading time, it will allocate the memory. Those will be available across your program execution, not only a single method. Okay. So like, do we need to use static every time? No. Okay. Depends on our requirement, whether you want to waste your memory or you want to decrease the memory. That depends on you. Right. So wherever you require, suppose even though I declare like this, it will not occupy any memory. Okay. So here what happens is, whenever you create the memory, whenever you specify the memory allocation, that time only memory will be allocated and that you can use it. But to process this data, you cannot directly process in the main method. Main method only can call other methods. Even though you call this method, you call this int c into division. Into division method. Okay, here it will not give you any error, but while calling this method into your main method, it gives you the error. So suppose if you make it as again static, it won't allocate the memory for your C variable. Again, at C level, you will get error. Again, you have to make it as a static. But instead of it, what you can do is you can create the memory and you can access it. Okay, so how we can create the memory? Okay, so if you want to create the memory for your class variables, which are non-static, So let me remove method names for methods also remove static. Okay, we have one syntax. Okay, you are creating a new memory, you have to use new keyword. Okay, whatever the type you want to create. Suppose if I use int type of memory will be created, right? Similarly, whatever the type you want to create, use that type. So I want to create calculator type. This entire memory is a calculator type. So when you use this, memory will be allocated. Okay, and this entire data will be stored into that memory location with this format. If you want to store into some variable, okay, you can store into some variable. Again, you have to provide the type. Okay, why we need to provide the type? The same type only we have to provide. Why we need to provide the type? So generally, we can do declaration and initialization separately, right? Okay, so I can declare calc like that. Okay, if you want to assign the data, okay, you can assign the data and memory location like this. Okay, so here this memory location type you are specifying it as a with the data type which you are using, and this is the variable name. Both you can do. Okay, here it will specify the type and also it will allocate the memory. Both you are doing it. So not both, sorry. So here you are just allocating the memory to specify which is a type of this particular calculator type. You have to use this data type both separately. Okay. So after allocating the memory, what happens? All these things, all these values will be stored into memory location. So if you want to access one by one value, so you have to use that memory location name and subproperty. Memory location name and subproperty. Like this you have to use. So let me remove static for division also. Okay, but here the problem is, so you already allocated the memory. Suppose if you want to create one more copy, yes, you can create one more copy, but name you should give it as different name. Duplicate name you cannot use because this is also comes under variable and data type only. You cannot create inside a single block, you cannot create duplicate names. When you create like this, again separate memory will be allocated. Okay, again separate memory will be allocated, and if you perform any operation on this global data, okay, it won't affect on other memory copy. In other memory copy it won't affect. Okay, let me create few diagrams to explain this, then only you can understand it. Okay, so you have a class. Okay, when you use static. Okay, so your JVM will be allocate one memory for your static variables. Okay, when you use new keyword, and if you use this method, this is a special method inside this logic, inside this method. So we'll have memory allocation logic. Okay, new memory will be created with this logic. Okay, yeah, so like that. So why I'm putting it as a circle? So generally this memory location we call it as object. Okay, so that is the reason I'm putting it as a O. Okay, object. So some separate memory will be allocated. To this memory, it is a type of calculator. Sorry. So this calculator memory, you are providing the name as calvo. Calculator, just calculator, calci. Okay, so this you are created. So when you use again one more statement in backend, again you are asking to create the new memory. Okay, so again it will create one more memory. Again it is a type calculator, and a different name you are giving to it, calci1. You are providing the name as calci1. Okay, it is representing this. So this is a separate copy. Again, this is a separate copy. So inside that you will get int a equals to some 10, int b equals to 20, int c equals to 30, and also you have methods. Okay, so methods addition, subtraction, division. So you have multiplication as well, right? The multiplication, division, and modular division. Okay, so inside these methods, if you create any local variables, okay, for those, again separate memory will be allocated. Okay, this we call it as method area. Method area. Okay, this is instance memory. Okay, each instance it is creating memory. That is the calling that's why we are calling it as instance memory. This is also instance memory. Instance memory. This is also memory. And this is static memory. Static memory. Okay, so these methods, for these methods, okay, method area will be allocated. Okay, if you create any local variables, those will be stored into method area. This method area. Okay, for each and every class, method area will be separate again. Okay, so here in our example, we are using C and D, right? So C and D will be stored into this method area. Okay, so whenever you call this addition method, okay, in this method area, these values will be, this memory will be stored and it will be destroyed. This method area will be destroyed once this addition method execution is completed. This will be destroyed immediately. Okay, once method is executed, it will be destroyed immediately. But coming to instance memory and static memory, these are fixed memories. Okay, until your program execution, until you complete that program execution, these memory will be available. Okay, so that is the reason we always, most of the time we use local variables. Okay, global variables, very important data only. For the mandatory data only, we will use the global variables. Otherwise, we have to go with the local variables only. Because this memory is always, getting erased, right? Okay, your process, your execution process also, it will increase. But coming to the important information, again, you have two categories. Okay, if you want to create different copies or whenever you require, there only if you want to create and use it, then go for the instance. But I need a memory, I need some data that should be available across my program. Okay, that I want to access anywhere. In that case, I have to go with the static data. Okay, so whenever you create like this for a class, suppose if you have some static variables, those you can access with the this object, this particular object variable. Again, with this object also you can access. Okay, this is also a memory which is related to calculator. Okay, calculator static memory. Suppose if I create int d equals to 40, I want to make it as static. Okay, so this d value comes to this static memory location and it gets stored here. Now you can access this data, whatever you have this data, you can access with this calculator 1 and this calculator 2 object. Okay, the same data you can access here. Okay, so method area is common. Okay, runtime, it is common for all the objects, method area. Okay, not only a single class. For all the classes, method area is common. Not only instance class, calculator class. If you create any other class, method area is a common area. Okay, so at a time it can like execute only one method, right? Okay, so method area is a common, so it will automatically process that method and it will destroy that method information once it is executed. Okay, for this object also, for this memory location also, so methods, whatever the methods you have, okay, the method area will be common. Okay, so now, so here when you create more than one object, more than one instance, okay, separate memory will be allocated. Separate memory will be allocated. Okay, so if you declare with the static, okay, it won't allocate memory for the static d value. It won't allocate into the instance memory location. It create a separate memory, so there it will be stored. Okay, so generally, so if you have some data, okay, that some common data, okay, to share with all your objects, all your across all your objects, all our object means, so generally with the help of classes, okay, suppose if you take student class, student class, Okay, we will create the prototype for that student. We create model class for that student. Okay, so students, we can have more than one student, right? So if you directly initialize some name, if you directly assign some name, okay, that will be applicable for only one student. So you should not do that. Okay, so basically we create a prototype model. Okay, that model for that model we create the object and we will store the data. For example, suppose student can have name, right? String student name. Do not initialize any value. Okay, do not initialize any value. Roll number, some int roll number. Okay, so class name string. If you want, we can put other properties as well. Student first name, student last name. Okay, these we will see later. So generally we create the prototype. Okay, for all the students, suppose I can create multiple students now. Okay, to create the memory to store the student data, you have to use new keyword and also you have to use this method. You need to call this method. What is this method? Where it is available? I will explain later. So you need to provide some name to it. Student one. Okay, student one data you can store, and so I want to assign name to student one. Student name equals to some student one, roll number, some roll number. So roll number I will assign as someone to someone. Okay, class you can class can be class name. So class is a string some 10 class. This is student one. Okay, so if you observe here, suppose if I want to create one more student two, I want to assign student two. Into the student two, I want to assign student two data. Okay, as I explained, so here, whenever you use new student like that, it allocates separate memory always. Okay, so let me duplicate it. So now I'm creating student one. Okay, this is student one, and also I created student two. I will create student three and student four. Okay, student two, roll number two, again 10th class. I want to create one more student. Again, I want to create one more student. Total 4 students I want to create. 4, sorry, 3. This is student 3 and roll number 3. Student 4 and roll number. Student 4 and roll number 4. Okay, so student 3 here. Like that, I have 4 students. Okay, so let me take these values. Let me assign values as well. Let me remove the type. Student name, student roll number, and class name. Student 1 and roll number someone. 10th class. Okay, so now, so let me create other students. So just copy it. So there are one more student, student 3 and student 4 I have. Okay, so whenever we create object every time with new keyword, okay, so backend, so for each and every time, memory will be allocated separately. Okay, so this is student 1, this is 2, this is 3, and this is 4. Okay, you can access the data with the respect to reference ID. Respect to reference ID. If you want to access student 1 data, you can use student 1 variable. Okay, if you want to access student 2 data, you can use student 2 variable. Similarly, student 3, student 4, you can access with this data. So here the thing is, why we need to create like this? Why we need to create different objects? So when you create like this, in future, if you want to add some extra properties of a student, or if you want to change some student name, okay, so this will be easy if you create it as a separate. So if you maintain entire these all these students in a single object, it is very difficult. Okay, and also we are creating model, prototype model, okay, to perform the actions and to store the data. Okay, so here the thing is, so whenever you create new student, so every time class name is same, right? Every time class name is same for these all these students. So if you store that class name in each and every object, in each and every memory location, so this statement also occupies some memory, right? Okay, instead of wasting the memory, okay, to store this particular value, what you can do is we can create a separate memory for that, separate memory for that particular variable that we can store. Okay, so this value we can pass to, so this the value, so to access this value we can give the access to all these objects. Okay, so instead of maintaining it separately, class name, if it is a common data, so store this data into some other memory location and give a access to it. Okay, so like that we can save some memory, save some memory. So static, when you use static, it will not allocate separate memory. It will not allocate separate memory. It allocates a common memory to be accessed by the other all objects. So now you can save the memory. If you have some common data shared by objects, you can maintain into some common memory location. So from there you can directly access. So here, even though you assign like this, suppose if you want to print student class name, okay. So what I do is instead of assigning like this, so this class name I will store it as static. This I will assign directly from 10th class. Okay, so no need to assign here, again here. And similarly, no need to write some huge code. Yeah. So now if I want to know, so just I assign the class name only. So I'm not assigning with specific student. But if I want to get the student one class, okay, it prints that student one class name. Similarly, student two also you can access directly, not only student one. Okay, we didn't assign anything with the particular object, but still we are able to access that student class name. Okay, whenever we have some common data, okay, it's better to create a static memory for that. Okay, common data which you which you don't want to like change. Even though you change, if it is applicable for all your objects, then you should consider it as a static data. Suppose you have some students. Okay, so generally students one by one class only they will promote, right? Okay, from 8th to 10th, 10th to 8th to 9th, 9th to 10th, like that only it happens, right? So some students they jumps some classes from 8th class to directly 10th class. Sometimes they will jump. Okay, suppose student one is there. Okay, he is is jumping from 8th class to or 10th class to intermediate second year. Instead of first year, it is directly moving to intermediate second year. Suppose if you change that data to class name, is directly jumping to some 12th class. Okay, all the remaining people are after 10th, so they are 11th class. Okay, first year class, intermediate first year class. But if you assign 12th class to student one, okay, again if I print student one and student two, okay, for student one it has to print to 12th class, my as per my requirement, and student two class it has to print 11th class. So let me make it as some 11 here, 11th class. Okay, in this case both the students are, okay, let me put it as 10th, and student to 11th class, student to 11th class, or consider student 2 is jumping to, student 2 is jumping to 12th class. Okay, student 2 is jumping to 12th class and student 1 is jumping to 11th class. Similarly, student 3 also, okay, 11th class, and student 4 also 11th class. Okay, so here if I want to print student 3, okay, what is the value it has to display for student 3 and student 4? My requirement is student 2 only should move to 12th class. All the remaining students are 11th class. Or let me assign the value as class name as 11th. But for student 2, it is 12th class. Okay, so let's see the output. Okay, so initially all are 10th class only. Okay, initially all are 10th class. Initially all are 10th class, but coming to student 2 is jumping to, and all other students are jumping to 11th class, but coming to student 2, it is 12th class. But if I run it, see, First, it is printing all our 10th class, right? But I assigned 11th class to my all students. But only for student 2, I changed it to 12th class. When I print, it has to display, for student 1, it has to display 11th class. For student 2, it has to display 12th class. And 3 and 4, it has to display 11th class. But still, I'm getting 12th class. Okay. So that is the problem with static variables. Okay. Whenever you are choosing it as a static, okay, so with any object you change, with any object, if you change the data, okay, it changes to all your objects because it is maintaining only one copy. Okay, not multiple copies. Not multiple copies. It is maintaining only one copy. Even though you change with student 1, student 2, student 3, or student 4, it is applicable for all your object. Suppose if you make it as 11, it will be applicable for all these objects. So here you change it to 11. Again, immediately you are changing to 12th. Okay, so in this case, it is 12th. So when you are printing, it is taking 12th class. Okay, based on our requirement. So you need to identify the common data. What is common data and what is instance data you need to identify. Okay, when you make it as a static, okay, generally static data we won't change. Okay, even though you change, it is applicable for all the objects. Most of the time, we don't change that static data. Okay, so some cases only we will do that. So for that common data, if you are not changing, you whenever you use static, your JVM only take care of memory allocation. No need to do it manually. Your JVM only will do that. And when you use new keyword, it won't allocate memory for your static because it is already available and it is created by your JVM. Okay, so for the remaining fields only it will allocate the memory. Okay, and also, okay, these things will happen, generally, right? So instead of, if you don't want to, change the class name, you want to create a separate student class for 11th class. I mean 11th students. I mean 11th class students. 12th class students. If you want to create a separate class, okay. In that case, instead of changing this class value, what you have to do, you have to create a separate class for your 11th class students. For 12th class students, you have to create a separate class. Okay, like that you have to maintain. Okay, so the student class is common only. You will create one more class for 11th class student, one more class for 12th class student, 10th class student. For one more class you will create. You will provide the relation for this prototype. Okay, how to do that we will discuss in the inheritance. Okay, so if you don't want to change, this value, okay, so what you can do is you can restrict the operation to change the value. Suppose if I make it as a final, okay, if you try to change the class name, so let me try to change the class name here. So earlier how we are changing class name equals to, we are changing it as 11th class and we are changing it as 12th class with student 1. Okay, this is 12th class, like that we did. Okay, so it will not allow you to modify. Okay, that option we have final, but sometimes we might change that data. Okay, way to change that I will explain with one example. Okay, so this one is not allowed. And also you can create different methods. Void display student details. Okay, display student details I can create. Okay, what I have to display, I want to display student name, pledge. student name. Okay, if you want to display student roll number, roll number. Similarly, class also, if you want to display, yes, you can display student class. You can use class name. Okay, if you call this display method here, okay, so again, this method is a, if you don't specify static, it becomes instance. Okay, it becomes instance. So now this method will be created inside, okay, all your objects. So when you call display student details, you have to call with that reference, whatever the reference you created that for that particular memory, with that reference only you have to call. Suppose if I call with student one, what it will display? Student one details which it will display, not all other students, because it is available in student.display. Each can access these details. It cannot access other student two details. With this method, it cannot access other student two details because it is available in this particular memory location. So if I run it, see student one details are displayed. Student one. Okay, I want to display student two. So simply you can use student two, but the method is same. Okay, only you create a single method. So like you create variables, single variables. When you create a copy, so all your methods, it will create a copy and it will store it. Okay, so you are accessing with this reference. Okay, it is a collection of properties. So now what you are performing, or what is object? It is a collection of properties. Properties of some data types, properties of some class, collection of some data, some class data that you are accessing with that object reference. You are accessing class name, you are accessing student name, okay, you are accessing roll number, and also you are accessing method, these properties. It is a collection of properties, is a object, okay, which have some type, whatever the data type you created the object, so that with that type only we have to call student object or college info object, faculty object, like that. Yeah, so I have small concept, so I will explain that. After that we can close our session. So see, here we are writing, okay, class name, variable names, and also final. Whenever you use final name, so you are also like using some variable, final variable. Generally we call it as final variable. Okay, methods we are writing. Okay, so four types we are writing. Class name we are using, normal variable name, static variable name, and also method name we are using, right? So we have some rules to write. We have some rules to write these names. Okay, we should not randomly take some name, or we should not write like that. Okay, we have some names. So sorry, we have some rules to write the names to your classes, your variables, and also your methods. What are those rules? Okay, so technically we call it as naming conventions. Naming conventions of class, method, and variables. Naming conventions of class, methods, and variables. Okay, not only class, you can put it as interface and enum. Okay, so suppose if you are creating a class block or interface block or enum block, okay, class, interface or enum. So you have to use the naming format. You have to use the naming format as okay. It should starts with okay. It should starts with big letters. Okay. So generally this we call it as Pascal case. Pascal case. Pascal case means in each word, first letter should be capital, capital letter, big letter. Okay, when you are writing method or variable, in each word again, first letter should be capital, the same thing. But for first word, for first word, first word should be in small letters. First word should be in small letters, and from second word onwards, from second word onwards, and from second word onwards, first letter should be capital. Okay, these are the basic, very basic rules we have to follow. We should not write our class names and the method names. Okay, as per our understanding, it should be understandable by everyone, not only you. When you are writing some program, everyone has to understand that program. Like that, you have to write your program. Okay. Okay, so variables again we have two types, right? Okay, that I will explain. Okay, suppose I have a class, calculator class, calculator. We are writing inside that calculator. We are writing variables and methods. Let me take it as student, student, student name, student, student name, roll number. Okay, and we defined class name, display, student details. Okay, so by looking at these five names, okay, you already written the program, you might understand okay which one is representing the type. Okay, suppose if some new person is looking at these words, how he can differentiate which is class name, which is which is variable, which is method. How we can differentiate? Okay, generally for methods we put the parenthesis at the end of the statement. You can recognize it as a method. But coming to others, we have variable and class. How we can differentiate which one is class and which one is variable? Okay, and also in English also, okay, you cannot directly read it as a student name. You cannot read it as a student name. Okay, so you have to read it as a student name. There should be a gap, or it should be in a readable format. So that is the reason for methods and variables or classes. Okay, each word, first letter should be capital. Suppose if you put it like this, okay, it can be easy to understand and easy to read also. Okay, so roll number you have to write it as a roll number like this. See what is this class? class name, right? If you write together in a single, in a smaller case, it is not easy to read properly. Okay, if you look at this display student details, okay, if somebody sees this, he cannot understand what is this. But if you write like this, okay, they can simply understand by looking at the capital letter. Okay, new word is starting. Okay, up to this part, one word, and from here another word, like that. Display student details. If you write like this, it is easy to read and easy to read and easy to recognize. Okay, so to differentiate class name, so we have to follow the Pascal case. Suppose if you have student, you have to start with capital S, but variables and methods you have to start with smaller case. So this technically we call it as camel case. Camel case. One is Pascal case, another one is camel case. Start with small letters and it will raises its name. Camel case. Come into class interface, when you are writing student, college student, okay, or student details, like this. Suppose if you are taking bank transactions, like this, you have to write. It is easy to read and easy to differentiate. Suppose by looking at these names, now we can easily say, if you write like this, if you follow these rules, okay, by looking at your program, okay, it is starting with capital letter, which means it is a class. Okay, so generally, suppose if you have some calculator, okay, so this calculator, I have some static value, some D, so D is already static, right? So here we can directly access calculator information to our class. That happens in the inheritance. Okay. So let me use inheritance now. Okay, if I want to print that variable, static variable, I can directly print here. Let me print. That D value I can directly print here. Okay, so to differentiate, you can print like calculator dot D. Also, you can print. So in that case, no need to extend also. For suppose if you write a calculator class name as small c. Okay, so now you are getting error. Ignore it. How you can differentiate whether it is a class or variable, like this? Whether it is a class or variable, can you differentiate? You can't differentiate, right? Okay, you can't differentiate. So that is the reason we have to follow the rules. Okay, these naming convention rules. So you always write your class interface enum with this naming format, Pascal format. Each word first letter should be capital letter. For coming to variables and methods, you have to follow the camel case. Okay, so first word should be in small letter. From second word onwards, you have to follow the Pascal case again. It is a combination of camel case plus, not camel case and Pascal case. It is a combination of both. First word should be in small letter. From second word onwards, each word should be capital letter. Each word first letter only. Okay, again, you should not write like this. Student name, like this. Just write student name. Okay, so in variables, we have, so this is the method. Okay, fine. Student class and method I am able to differentiate, and also variables also I am able to differentiate because it doesn't contain any parentheses. Okay, which means variable. But in these variables, we have normal variable and final variable. Okay, normal variables, you are able to change the data for normal variables. Coming to final variable, you cannot change the data. Coming to final variable, you cannot change the data. If you try to change the data, you will get error. Okay, if somebody using your program, he wants to update the he wants to update the class name for all the students. He wants to update the class name for all the students. If he tries to access that class name, he will get error. He may not understand because when you follow all these, basic rules, abstraction process and everything, he cannot see your code. But when he might be able to access your code, but at least he cannot see your code. In that case, how he can understand whether it is a normal variable, okay, or final variable, how we can understand it. Okay, to differentiate normal variables and the final variables, we have to follow one rule. Whatever you write, okay, that you should write in a capital letters. You should write in capital letters. Suppose if you are writing class name, okay, again, you should not, everything you should not write in capital letters. If there is a single word, write like this. If you have more than one word, differentiate with underscore, like this. Suppose if you follow this naming convention, for class name, if you follow naming convention like this. Okay, so you can easily understand that, okay, it is a normal variable. It is a final variable. This we cannot change. It is a class. Okay, it is a method. Like that, you can understand your program and also others programs also you can understand easily. Okay, when you start writing in this format, then you can understand others programming. Okay, so by default we will get some packages, right? Okay, to understand those packages, so we have so many packages, so generally we don't create much logics. Existing logics only we always use. Okay, existing logics only we always use. So suppose if you take JRE library, if you take Java package or any other package, okay, so let's take Java SQL package. Okay, so inside Java SQL, okay, you have two more packages. So there are some classes. Okay, these you can reuse into your programming. How you are reusing these primitive data types and these reference data types, right? Similarly, you can use these packages. Okay, if you expand it, you can see the variables and methods. So these are the methods which are in green color. Okay, so there are some variables. Okay, sometimes you can see some see all these are in capital letter. Why all these are in capital letter? Some are in capital letters, some are in Pascal case, camel case, some are in camel case, some are in camel case variables. These are methods. Then how you can understand the existing class information? Okay, by looking at its name only, you have to recognize it. Okay, it is a final variable. You can use it only. You cannot change it. Okay, this is the method. Okay, this is the method. Okay, it is a normal variable. Like that, you have to understand. Okay, this is the class. By looking at its name, okay, this is the class names or interface name or enum name. Like that, you have to understand. Okay, yeah, so you have to follow these naming conventions while writing your programming. Okay, so tomorrow I will explain, about the static again, static and instance, because these two are the very basic concepts to understand the Java programming. These are very, very important concepts to understand Java programming. Okay. So tomorrow I will take one more example. Like student, I will take some bank transaction example. There you will understand when to use static and when to use instance, and why we need to create multiple memories, multiple instances, why we need to create, that you will understand tomorrow. Okay. Yeah, so I will continue tomorrow. So I will stop recording.